I hope you took a moment to look over the previous slide that showed when to use which cases and what you could find by using the particular laws. Some people definitely have a question about which law should you use when, and I can understand that because sometimes we use both laws in the same problem. Just have to decide which one to use first. So this particular set of problems, these sample problems, I like because the directions say do not solve. They just want us to choose the law and set up the equation. So for number 1 here, if we look at it, we have got side-side angle, or we could say angle side-side. Either way, whether it's angle side-side or side-side angle, that's going to be the law of sines. We will have to worry whether or not it's an ambiguous case. Side-side angle did not guarantee congruency. Sometimes it worked, sometimes it didn't. So there may be a non-unique solution here. There may be more than one triangle that satisfies the proportion when we set it up. The calculator is going to give us an acute angle. There may be an obtuse angle that has the same sine value. But because this triangle already comes equipped with an obtuse angle, in this problem we won't have to worry about it. It's not possible to have two obtuse angles in the triangle. So we can just go ahead, set up the proportions that the sine of angle x divided by its opposite side is going to have to equal the sine of 112 degrees divided by its opposite side, and we won't have to worry about getting the second angle that has the same sine value. That's it, just do the problem. Number 2, they gave us side, angle, side. So side, angle, side, for that we use the law of cosines. We do not have an angle and its opposite side. So we're going to try the law of cosines. We are looking for this side. We do have its opposite angle. So we're going to have this side squared on one end of the equation and the cosine of its opposite angle at the other end. In the middle, we're going to have the lengths of the other two sides filling in. So we'd have x squared equals, and then the other two sides squared added together minus 2 times those other two sides times the cosine of the opposite angle. And we could just poke all of that in the calculator, find out who x squared is, take the square root, and we're done. Number 3. Well, they gave us all sides. There are no angles given at all in this problem. So side, side, side is definitely going to be the law of cosines. They are asking us to find this angle. So that's going to be at one end of the equation. And its length of the side that is opposite to it will be at the other end of the equation. So this can start off using the law of cosines as 30 squared is going to have to equal the sum of the other two sides, the sum of the squares of the other two sides, minus 2 times those other sides times the cosine of angle x. Now I'm emphasizing the cosine because another frequent mistake is that people write out all of this stuff and then they write sine of the missing angle. And that's what they put in the calculator. No, it's called the law of cosines for a reason. End it with the cosine of x here. Number 5. They gave us an angle and another angle and a side. Well, angle, angle, side. That means use the law of sines. Whoops. So we do have an angle and its opposite side, another angle, and we're looking for its opposite side. We could say either the sine of 100 degrees over x equals the sine of 42 degrees over 56. Do cross products. Some people find it easier to write x over the sine of 100 degrees equals 56 over the sine of 42 degrees, and then they just have to multiply both sides by the sine of 100 degrees. If that looks easier to you, go for it. Number 5. They gave us 2 angles and a side, so it's angle, angle, side. We're going to be using the law of sines then. And we have that 20 is opposite to angle 40 degrees. They want us to find this side, but we do not have its opposite angle. But we already have used up 148 degrees in these 2 angles, which means this angle has got to measure 32 degrees. And now we do have enough information. We could say x over the sine of 32 degrees has to equal 20 over the sine of 40 degrees and solve for x. Number 6 is almost identical to number 2, so we're going to skip it. If you'd please find the second sheet, which has on it in the middle Roman numeral 3. So for Roman numeral 3, they want us to actually go ahead and solve them. Okay. Well, they gave us an angle and an angle and a side and a side. So we're covered all over the place here. And they want us to find the dimensions and round the answers to the nearest whole number. So we've got angle, angle, side. We've got, enough to go on here. We do have angle, side, side. But we won't have to worry about this being ambiguous because of the angle, angle, side, and because we have this obtuse angle. So we are going to use the law of sines. And to complete the triangle, it's not too hard to find this. We've already used up 158 degrees. The measure of angle F has to be 22. We still need to find side F. So we could say that side F divided by the sine of 22 degrees, because that's its opposite angle, is going to have to equal 19. Or we could have used 8 over the sine of 138 degrees. So side F is going to have to equal 19 over the sine of 138 degrees times the sine of 22 degrees. And we just put that in the calculator. So if we type all of that into the calculator and round it to the nearest whole number, we find out that F is approximately equal to 9. That does not look like a 9. So number 12, we're given side, angle, side. Side, angle, side means use the law of cosines. And they want us to find the measure of angle C. So we've got two sides, we've got an angle. If we're going to use the law of cosines, we would have the cosine of angle C at one end, and we would have the length of side C on the other end. Unfortunately, we do not know the length of side C. So that's not going to work. And we can't use the law of sines because we don't have any angle on its opposite side. Maybe if we rethink this. Maybe if we think of the 15 and the 19 as being the other two sides. Because I misspoke, we do have the side opposite to angle C. The side opposite to angle C is the 15. So we would have cosine of angle C here, we would have 15 squared here, and then we'd have to know the other two sides. We don't know the other two sides. So we can't put 15 squared equals middle two sides and the cosine of angle C. We're going to have to rethink it. Maybe let the 15 and the 19 be the other two sides. And go for the side that's across from angle B. Try to find side B. So now we have 120 degrees is the angle opposite side B. We have the lengths of the other two sides. We can go ahead, use the law of cosines, and find side B. Maybe then we'd have enough information to get angle C. So we have B squared is going to equal the 15 squared plus the 19 squared minus 2 times 15 times 19 times the cosine of 120 degrees. And we can put all of that in the calculator. I'm going to give that a try here. Clear out the old answers. Try 15 squared plus the 19 squared minus 2 times the 15 times the 19 times the cosine of 120 degrees. And we get 871. That's what B squared is worth, is 871. So now we'll ask the calculator to take the square root of that, and if you're using direct entry scientific, on this calculator I'm going to take the square root, second square root there, and then second answer, second negative equals. And it's saying that it's 29.5. So B is approximately 29.5. Now they want angle C to the nearest whole degree, but I'm just going to keep angle B at 29.5 for a little bit of precision. So we still don't know who angle C is. But now that we know side B and its opposite angle, we can find angle C here because we know its opposite side. So we can say that the sine of angle C over its opposite side is going to have to equal the sine of 120 degrees over its opposite side. And then we can multiply both sides by 15, and do inverse sine of that whole thing. So I'm busy typing in this equation here. Still have to do divided by 29.5. And it gives us this beautiful decimal, which is the sine of angle C. So now I'm going to do inverse sine, second sine of that answer. And it tells us that to the nearest whole degree, angle C is going to measure 26 degrees. So this is a 26-degree angle here. Number 13 is almost identical to number 12, so we're going to skip it. Number 14. They gave us angle side-side. Or we could say side-side angle. We are going to have to use the law of sines. And we're going to have to be on the lookout for the ambiguous case. Because this angle that they gave us is an acute angle and not an obtuse angle, it's very likely that there's more than one solution to this problem. So they want us to find side F, which is fine. That's across from angle F. But they didn't give us either one of them. They did give us angle D and its opposite side. And they gave us the side that's opposite to angle E. So it is possible to find angle E first. And then once we know who angle E is, we can find out who angle F is, and then we can find out what side F is. So if we tried the law of sines, the sine of 36 degrees divided by its opposite side, is going to equal the sine of angle E divided by its opposite side. So the sine of angle E is going to equal 71 times the sine of 36 degrees divided by 62. And we can then do inverse sine on all of that. On all of this. Okay. So it turns out that angle E could either be 42.3 degrees or angle E could be 137.7 degrees. With the 36 degrees we already have, each of these angles is a possibility. So there are two possibilities for angle E, two possibilities for angle F, and that makes two possibilities for side F. And we're not going to do this right now. If you could please find the sheets that are labeled word problems, and they had directions that went with them. Now the directions for the laws of sines and cosines word problems are very specific. We are being asked to draw a sketch, to write the equation filling in the information, to show some kind of evidence, even if it's only what we type in the calculator, and to round all our solutions for this particular set of problems to the nearest tenth, and put the answers in complete sentences that relate the answers to the context of the problem. So I know this looks like fun. We'll get started. So number 1 seems like a good place to start. Going to make the drawing first. Says we have a post supported by 2 wires, one on each side in opposite directions, creating an 80-degree angle between the wires. Okay, post. Poor post there. And 2 wires. And we have an 80-degree angle between the 2 wires. We're also told that the ends of the wires are 12 meters apart on the ground. One wire forms an angle of 40 degrees with the ground. Okay. So I'm going to let this be the 40-degree one. And they want us to find the lengths of the wires. And I forgot to write down that they are 12 meters apart. Well, we know that this angle's 40. We know that this angle's 80. So this has got to be here a 60-degree angle. Which means these 2 wires are not the same length because they have 2 different angles down here. So we can't just cut 12 meters in half, and we're going to have to use the law of sines or law of cosines. So we are given all 3 angles and one of the sides. We could call this angle, side, angle. Angle, side, angle would work. Or angle, angle, side. Either way, this is going to be the law of sines. And they want us to find each of the 2 wires. So I'm just going to call the one across from the 40-degree angle X, the one across from the 60-degree angle Y. So to find the length of angle X, we know its opposite side. In the same triangle, we have an angle, and we know its opposite side. So we could say that X over the sine of 40 degrees is going to have to equal 12 over the sine of 80 degrees. So that would imply that X is going to equal 12 divided by the sine of 80 degrees times the sine of 40 degrees. And we can just put all of this into the calculator, find the result. So it does help if you type it in the calculator correctly. Instead of divided here, I should have said times the sine of 40 degrees. That gives us a much more reasonable answer. So that would imply that X is 7.8 meters. But that only gives us X. We have to continue, find out who Y is, which is going to be a very similar setup. It's going to be Y over the sine of 60 has got to equal. I'm not going to go with a 7.8 because that's a rounded off answer. I'm going to keep with the original 12 and 80. So we do have a problem very similar to what we had before. 12 divided by the sine of 80 degrees times the sine of 60 degrees should give us the length of the other wire. So looking at number 2, we have 2 ships sailing from Halifax, major port in eastern Canada. The Nina is sailing due east, and this is really cute. The Pinta is sailing 43 degrees south of east. So the Nina is leaving from Halifax, sailing due east. The Pinta is sailing 43 degrees south of that. And they tell us that after an hour, the Nina has traveled 115 kilometers, and the Pinta has traveled 98 kilometers. And they want to know how far apart are the 2 ships. So this is a classic case of side angle side. And side angle side means we're going to use the law of cosines. We are looking for this side. We have its opposite angle. We have the lengths of the other 2 sides. So we can just go ahead. We're going to have this length at one end, the cosine of that angle at the other end. So x squared has to equal the square on 98 plus the square on 115 minus 2 times 98 times 115 times the cosine of that opposite angle. We can put all of this in the calculator, and it will give us some beautiful thing. Which I really didn't need to write down if I'm using the calculator. I could just put second square root, second answer, and it would say that x so to the nearest tenth, we get something like 79.7. Now we need to put that in a sentence. 1 hour after leaving Halifax, it's supposed to say Halifax. The 2 ships are, and we could actually name the ships, .7 meters apart. That one wasn't as long as the last one because we only had to find one answer. I'd like us to just look at number 4, please. We won't actually solve it. We do have 2 scuba divers that are below the water surface, and the 2 divers are 20 meters apart. So we have diver 1, diver 2, and they are 20 meters apart. Now for the rest of this problem, there is more than one interpretation. And to get the answer that is given, when these 2 divers both spot a shark that is below them, and they give us the angle of depression from each of the divers, want to know how far is each diver from the shark. But the way the problem is set up, to get the answer they wanted, the shark has to be between the 2 divers. It is possible to do this problem with a shark off to one side. But for this one, the shark is down in between the 2 divers. So my shark is definitely not going to be frightful. Angle of depression means down from the horizontal. Angles of depression and elevation are always measured from the horizontal. So from diver 1's point of view, looking down to the shark is 47 degrees. That 47 is not showing up too well there. 47 degrees. Likewise, from diver two's position, looking from the horizontal down to the shark, this is a 40-degree angle. And that's the setup they're looking for to get the answer that they chose to write. Did also want to review about angle of depression. And let's move on to number 5, which is going to be our final problem for this set. So for number 5, Caleb's going to estimate the length of a lake. Okay. We got a lake with a very ragged shoreline here. It says he's going to start at one end, walk 95 meters, and then turn onto a new path and walk 87 more meters to the other end of the lake. So he's walks 95 meters. And then he turns and walks on a new path, which is 120 degrees to the direction he was first walking in. Okay, now that doesn't mean he made a 120-degree turn to get to the other end of the lake. It says if we consider the direction he was walking in, he made a 120-degree turn from that direction. Not that he made a turn 120 degrees. He made a 120-degree turn from the original path. So that makes this a 60-degree angle back to the other end of the lake. And I'm just going to make the lake flood a little there. Pretend this is a straight line, please. And he did that for 87 meters. We're supposed to find the length of the lake. So we've got side, angle, side. And side, angle, side implies that we can use the law of cosines. I'm just going to call L the length of the lake. So we're looking for this side, we've got its opposite angle, we have the lengths of the other two sides. We can just set it up as L squared. It's going to have to equal the square on 68 plus the square on 87 minus 2 times 68 times 87 times the cosine of, I wrote that all wrong, didn't I? Shooey, 95 squared plus 87 squared minus 2, just forget all of this. So sorry. Really. Times 95 times 87 times the cosine of 68 degrees. Some people are just careless. So we can put all of that in the calculator. This is 60 degrees. Oh my goodness. I know you folks are much more careful than I am. So L squared ends up being that when it's put in the calculator. And then when we take the square root, we get that the length of the lake is about 91.3 meters, which is not a terribly big lake. So the lake because we got to write this as a sentence, is about 91.3 meters long. Short sentence. Finish the problem. So on the next slide is your assignment, which is a few more problems from this word problem sheet. So you don't have to do all the problems, but you still need to follow all the steps in the directions, please. I hope you enjoy it.